So welcome to this session. So we are going to begin another session or another part of our autotrophic nutrition. So this time around we are going to look at what we call light in a forest, in bracket, shaded environment. So but before we proceed, this one is also very important to note. So we have two kinds of leaves. I'm repeating, we have two kinds of what? Of leaves. We have what we call the sunny leaves and the shade leaves. Now, when we talk about sunny leaves, these are sun leaves. These are leaves which grow on branches that are exposed directly to what? To sunlight. Those are sunny leaves. Then we have also another kind which is called the shady leaves. So shady leaves, these are leaves that grow on branches exposed to light that goes through leaves. So that's also important to note here in light in a forest. So we are saying that the amount of sunlight decreases as light penetrates down the vegetation layers because the amount of leaf area increases. Now, when we talk about this, there's what we are going to look at, which is called the leaf area index. Now, leaf area index is that one-sided leaf area per unit area of ground. Now, take this note that a leaf has got two surfaces, the lower surface and the upper what? The upper surface. Now, when it comes to leaf area index, we are saying that this is the one-sided leaf area per unit area of ground. That side which has covered the area is what we are talking about. Now we are saying that the leaf area index, which is LAI, is equal to meters squared leaf area divided by the meters squared ground area. So that is the formula of finding what we are calling the leaf area index. E.g., we are saying that 3 meters squared leaf area divided by the meters squared ground area means there are 3 square meters of leaf area over each square meter of ground area. So the next bullet, they are saying that the greater the leaf area over a surface, the lower the quality of light reaching that surface. Now let us go ahead and look at the fate of light in a forest, in bracket what we are calling the shade environment. Now below there they are saying that the graph besides shows the energy in light of different wavelength reaching the ground in a what? In a forest. Now they are saying, so you can look at that graph which is drawn there where there is direct. Now they are saying that energy was measured in number one, we have direct sunlight that passes through the canopy. Yeah, there you are seeing there that graph. We have direct sunlight that has passed through the canopy. Then two, we have also what we call the sunlight that had passed through tree leaves. So the sunlight that has passed through tree leaves or through leaves. Then the other bullet is, as light penetrates the canopy, different wavelengths are filtered out and light becomes attenuated or reduced. Now, when we talk about tree canopies, I don't know whether you have ever seen those trees which grows like umbrella. They go on forming certain layers. You get until up to the top there. So now they are saying that as light penetrates through those layers, different wavelengths are filtered out, and this light becomes what? Reduced. Then two, we are saying that the denser the canopy, the more weakening of light light occurs. So the denser the canopy, the more or the weaker the light occurs. Then there we are saying that leaves with white hairs, and cuticle reflects more light than deep green leaves. People, I don't know whether you have ever seen such leaves with the white hairs on their surface, that those leaves reflect more light than the deep green leaves. So those deep green leaves, for them, they do what? They absorb more light than the white leaves which have got what? Hairs. Now, number 3, we are saying that the smaller the size of gaps in the canopy, the more weakening of light. So the smaller the size of these gaps in the canopy, so the less or the weaker the light that goes through, as you can look at that graph of ours. Now, when we try to look at that graph of ours, we are saying that under observation, we are saying that all wavelength of direct light reach the ground. All the wavelength of direct light reach the ground, because this light passes through gaps left by leaves. Hence, no wavelength is filtered out. So when we have a gap in the canopy, so that light, which is very direct, it will just hit the what? The ground, because there is no obstacles, or there is no what? Leaves which is going to absorb that what? That light. Then number 2, we are saying that of the light that passes through leaves, only wavelength in the range of 460 nanometers to 670 nanometers reach the ground, or in bracket what we are calling high transmittance to the what? To the ground, because of low stroke or no absorption by chlorophylls in the leaves. Remember the other side, we looked at the most light which is absorbed, and we said that one of 400 nanometers, and the other one was about 700 nanometers. That one which was on 400 nanometers was the blue what? The blue light, and the other one was the red light. So when look at this range, 460 and 670, that one reached the what? Reached the ground due to transmittance. So we looked at this up there. Or there will be no absorption, or this light won't be absorbed by what? By the chlorophylls in the leaves. Then number 3, the third observation is like this. The wavelength of visible light below, now they are saying below 440 nanometers and above, do not reach the ground after passing through the what? Through the leaves. So that wavelength which is below, or that wavelength of visible light below 460 and above, that one is being absorbed, or there will be no transmittance because of much absorption by leaves or by the photosynthetic what? Photosynthetic pigments, e.g. the chlorophyll. Now our observation number 4 is of the light that pass through leaves, wavelength 525 nanometers reaches the ground with the most energy, because it is least absorbed by the photosynthetic what? The photosynthetic pigment. So this I therefore sign out. Let us meet in the next part, where we are going to talk about the photosynthetic pigments. May the God bless you. Okay.